Hi all, in this video we are going to see about EIGRP. What is EIGRP and how does it work? Let's get into the video. First of all, what is EIGRP? EIGRP is Enhanced Interior Gateway Routing Protocol. It also works like a distance vector routing protocol, but it's an advanced distance vector routing protocol. It's a Cisco proprietary protocol, that is, it only deals with Cisco devices. It can't be able to work on other devices like HP, Juniper, whatever it be. It only runs on Cisco devices. Its metric is based on the K values. The K values are bandwidth, delay, load, reliability, and MTU. By default, bandwidth and delay are only enabled. So other MTUs are being disabled. So by default, we can simply say it as metrics are based on bandwidth and delay. And the formula to calculate a metric is bandwidth plus delay. That's it about a metric. Metric is bandwidth plus delay is said to be as a metric. EIGRP here supports authentication, but only MD5 authentication supports. No plain text authentication is allowed in EIGRP. EIGRP can do equal and unequal load balancing. What does it mean is, if you are having a metric same, then what all the routes are having a same metric will be given to the routing table. But if you are having a different metrics to reach a particular destination, those metrics will not be given to the routing table. Only the best metric from the table, only the best metric will be given to the routing table. That's what is a normal load balance. There is an equal load balance. Unequal load balancing means if we have a different metrics, that is one best metrics, only one is said to be as a best metric. There are some other metrics. All the metrics are being varying. They are not same. But by using a EIGRP unequal load balancing method, we can put all the ways to reach a particular destination. That is a different matrices into a routing table. That's what we call as the unequal load balancing. EIGRP works based on the autonomous system. That is the AS number. AS number is nothing but a unique identifier for a EIGRP into the network. That is in a network, so that they can able to communicate. It has to be same on the routers. It's just an identity for a router. Just identity for EIGRP network. That's just an identity for EIGRP network. Next is the AD value. There are two AD values as internal EIGRP and external EIGRP. What is internal EIGRP? The network that originates in the EIGRP, that is that originates within the same EIGRP said to be as the internal EIGRP. External EIGRP are nothing but which is being from other routing protocols and redistributed into EIGRP. Consider OSPF as one particular network, and that is being redistributed into EIGRP, and that route is being learned in the EIGRP network. So that network will have a AD value of 170. That is said to be as an external EIGRP. Since the origin of this network is OSPF, it is said to be as an external EIGRP. Next is EIGRP tables. There are three main tables that EIGRP maintains. That is a neighbor table, topology table, and routing table. Neighbor table. Neighbor table means first it needs to form a neighborship between the two connections, the two routers or two links, whatever it be. Essentially, it sends a hello packets, and there are certain information in the hello packets as AS number, then what is the network that is to be transmitted, K values, and authentication. This is all the information that is to be transmitted in the K values. They have to match, and once done, they form a neighborship. The information that carries in the neighbor table or neighbor IP and the local interface and the uptime. These are the information that will be in the neighbor table. And move on to a topology table. The information that forms with the help of a neighbor table will be gathered together and gets the information to the topology table. Topology table maintains the entire EIGRP network to reach a particular destination. So it carries the information about a feasible distance, advertised distance, metric. These are the information. Let's deal with the feasible and advertised distance in the upcoming slides. Next is the routing table. The best route from the topology table will be moved on to the routing table to reach a particular destination. That's the routing table. This is about a EIGRP table. Next, this is what I said. First, EIGRP forms with the help of hello packets, and then move on to the topology table, and then move on to the routing table. This is what I explained here. Next is the advertised and feasible distance. Let's consider this scenario. Over here is destination 3.3.3.3. So let's consider this router R3. It has to reach that destination 3.3.3.3 and it has a feasible distance of 5. Okay, just look into the router R2. It also needs to reach a particular destination with the advertised and feasible distance of 10 and advertised distance of 5. So what does that mean? You can just see here. Feasible distance is distance to reach a particular network from the router. That's what this router has a distance of 5 to reach that destination. Next, if you look at this router, a feasible distance of 10 shows that it has to reach a 10 distance of 10 to reach a destination. The advertised distance of 5 means how far the destination is from my neighbor. That's what it says. So the feasible distance of 5 will be moved to the advertised distance of 5 for the R2. So this feasible distance, R3's feasible distance, will be the R2's advertised distance. Okay. Next, if we just look into the R1, so what does it do? Its feasible distance 10 will be given as the advertised distance of 10 from R1. So this is 10, over here is 10, so this is advertised distance of 10 over here. And what about a feasible distance? So it should additionally add the distance between the R2 and R1. It has a distance of 8. So automatically it has a distance of 8. So feasible distance is said to be as a 8. In simple words, we can say as advertised distance is how far the destination is away from my neighbor, and feasible distance is how far the destination is away from me. That's it about advertised and feasible distance. Next is successor and feasible successor. What is a successor? Successor is nothing but a best route to reach a particular destination is said to be a successor. And a feasible successor is backup of the successor. It's said to be as a feasible successor. But all the routes all the EIGRP networks cannot have a feasible successor. So there is some certain criteria in order for a network to have a feasible successor. So that is our criteria is that nothing but a feasible distance of a successor should be greater than the advertised distance of the feasible successor. So this is what feasible distance of a successor should be greater than the advertised distance of a feasible successor. If you're not clear about it, let's get into the example over here. It will be much more better as compared to the statement. So let's get into this table. What does this mean is that just consider the 3 routers to reach a particular destination. Okay, this is R1, R2 and R3. First we need to set up a successor. So the successor here is 25, as it has a best distance, feasible distance is to be as a successor. So in order to find a feasible successor, the first step is that you just make a note of the feasible distance. That's a 25. Just make a note of a feasible distance and remove the R2 from the table. Just don't even look into this R2. Just make a note of this 25 from here. That's it. Then look into the advertised distance of the other routers in the table. So if you look into the advertised distance of the other routing in the table, it has a 35 over here and 20 over here. So which are all the routers that are having value less than 25 is said to be as a feasible successor. So here is 25. That value should be the advertised distance of the other router should have a less than 25. So here is 35. It's greater. Here is 20. It's lesser. So this R3 will become a feasible successor. That's what I said. The feasible distance of a successor should be greater than the advertised distance of a feasible successor. If you look into it, feasible distance of a successor should be greater than the advertised distance of the feasible successor. So that's the criteria to become a feasible successor. Next is some basic EIGRP comments. These are the comments from which we have seen the EIGRP tables. That is, initially forms a neighbor table, then topology table, then our routing table. So EIGRP neighbors table. Show IP EIGRP neighbors is a command. So what does it provide is neighbors IP and a local interface of our router and the uptime between the neighborship. This is what information that provides in the neighbors table. Next is the topology table is what are all the EIGRP networks available for a particular destination. Then the feasible and advertised distance of all the networks and the local interface via which interface it's just moving. This is the information that topology table provides. Next is a routing table. Routing table is filtered from the topology table. The best route will be chosen to the routing table, and then AD value and the best there is a network segment, next hop and the local interface. These are all the information that will be provided in the routing table. Next is unequal load balancing. What does it do? I ask actually before itself explain how does unequal load balancing work. Then it is based on the variance command. What is the variance is nothing but it acts like a multiplier so that it can be moved on to the routing table. How does it work? And we can just check it in the manually by using in the lab. We just check the variance in the EIGRP lab. So just make a note of it. Variance acts like a multiplier and variance can do unequal load balancing. That's it about EIGRP right now. If you have any doubts, just give a comment. That's it. Thanks for watching. Until next time.